welcome to Hence the Future podcast. I'm Mattimore Cronin.
I'm Garrett Lisi.
And today we're discussing the future of physics. That means we'll get into how our understanding of physics and reality has changed over time, where it currently stands today, and what sort of progress we might hope to make in the future. But before we get into all that, I'd like to just make crystal clear what the mystery is that you and all theoretical physicists are trying to solve. I've heard it described as we're searching for the source code of the universe. I've heard it as we're searching for a grand unified theory of everything. How would you describe the problem that theoretical physicists like yourself are trying to solve, and how have you gone about trying to solve it in particular?
Well, I think maybe a lot of people enter physics with grand dreams of figuring out, the source code behind everything. But really, when you start tackling physics and get to learn more and more about it, you get to learn just how much we already know, and how we already know the physics behind almost everything we can possibly have experimental access to. So as a graduate student, your ambitions get pared down quite a bit more to reality, and you're happy if you can make one little incremental increase in the body of knowledge. So ultimately, what we really want to know is not everything, but rather just more.
Yeah.
Right? So we want to know more about how the world works. And it's, you can start getting a little megalomaniacal and getting some ambitions to say, hey, we're really close, it feels like, to getting like a really full picture. So where it starts to look like things maybe are getting close to a complete picture of what reality is. But as you get to fill in more and more of your physics knowledge, you get to know just how ambitious that is, and it's probably not going to happen.
Right.
And you should be happy just if you can make any incremental improvement at all.
Yeah.
But yeah, ultimately, physics is just a pursuit of understanding how the world works using mathematical tools.
Yeah.
And mathematics ultimately is just an extension of common sense to an increasingly abstract level.
Totally. And it seems like a lot of people nowadays, like, are still thinking of the world in a very mechanical, sort of Newtonian way, like maybe not physicists, but your average person. So might be useful to just go through sort of how the field's understanding of reality has evolved from Newton, where you basically have like bowling balls moving around in a very mechanical
Yeah.
way, to more of Einstein's relativity, where it's all relative to you, and then quantum mechanics, all the weirdness introduced by that, and then sort of how you've gone at the problem from the relativity side and geometry, and how you've approached it.
Yeah, there are quite a few, I guess you can call them sort of wait, what moments in physics, where it started out like just thinking about the trajectories of projectiles, right? And maybe the Greeks thought that a projectile would travel up and then fall down, right? And then they're like, wait, actually no, they go in sort of these parabolic arcs, right? And then they would have charts for these things. And a lot of early physics was all about weaponry. So the just very early on, the value of a physicist was in improving weaponry.
Mm-hmm.
And that's sort of continued, and why a lot of funding still comes from the military,
Right.
and defense for science research. But anyway, it really started out just as common sense. What happens in the world and why, and how, but the scientific aspect of it is not, let's not just sit around talking about it. Let's actually test it. So this is what distinguishes science from other pursuits: is you go out and test things and modify your ideas based on the results of testing. And this is what really led to progress in science and progress in the world as a result of science. Is this whole idea of just being able to test things and modify your thinking based on what those tests come back. So we started with things we could have very easy visual access to. Apples falling out of trees, machines working, just how things would move around in reality, and it's Newtonian physics. Okay, we have easy access to it, but then there seemed to be inconsistencies in it. So we started dealing with light, and we started figuring out how light works. It's like, all right, well, now we know that light always travels at this speed, right? And it's like, but wait a minute, what if you're on a train and you shine a flashlight, right? Does it travel at that speed plus the speed of the train? No, the mathematical laws we figured out describe light say it always travels at the speed, regardless of what reference frame it's measured in. It's like, well, what's that mean? It's like, so that means that if you're in a moving frame of reference, that either your time is slowed down or your
Hmm.
distances have shrunk on that train that's moving. It's like, how, wait, what? So that's
Yeah.
like, and this is special relativity, that actually the world does work this way, that yes, the speed of light is constant, and it's actually the flow of time or the scale of distances actually change based on how fast things are moving, which is just totally mind-bending, and it's really hard to visualize. So you can start playing with that, and mathematically you start working out as a physicist. So it's like, okay, yeah, this is all consistent, it all works this way, it's just really freaking weird.
Yeah.
and
If
then they start and then they started working on like temperature and how temperature works, and how things at various temperatures expel energy. And it's like, well, okay, if something's continually expelling energy at different wavelengths of light, and those wavelengths carry the energy away, then eventually you get down to where it should be expelling all its energy very quickly, but we don't know that doesn't happen. Things cool down more slowly. So there actually has to be a one quanta of the smallest amount of energy that associated with something being expelled. So and this is where the idea of quantum mechanics came from, right? Is
mhm.
that amounts of energy are actually quantized, and that was very, very different. Nothing, we had never encountered anything like that. And before that, everything it had been like a continuous spectrum of what it could be. And then in quantum mechanics, it's like, okay, not only that, but if you look at like the position and momentum of moving objects, right? That we can't know their momentum and their position at the same time. That if you know its position, its momentum actually isn't even well defined.
Mhm.
Wait, what?
Yeah.
How does that even make sense? It's like nothing we encounter in the macroscopic world. It's entirely different. And so physicists have had to wrap their minds around these concepts that are entirely foreign to our scale as humans, right? As
Yeah.
humans, we never travel near the speed of light, so we never get to experience what that's like. And we're large. We're not down at the scale of atoms, so we don't see what quantum mechanics is like. We only have access to that experimentally through our apparatus, and but we still have to think about it and model and understand what goes on at that scale. And we've been really successful at doing so, but we no longer. But fundamental physics now no longer acts at a scale that we, you know, have interact with as humans. What we're interacting with as humans is like 8 scales up in emergence,
Right.
up to this distance scale and up to this level of complexity from the basic building blocks. And another wait what moment was like figuring out, when we got to know more and more particles, more and more subatomic particles, and this whole zoo of what particles exist, that they correspond to these beautiful, complex mathematical symmetry groups called Lie groups, after Sophus Lie, the mathematician who came up with them.
Hmm.
And to find out that these things have to do with elementary particles, then it all ultimately comes back to geometric shapes, and how these uh, different high dimensional surfaces are shaped and interact and evolve around one another. The
Right.
fact that you described the whole universe of particle physics this way was really a fantastic thing. It was probably an equal revelation to that of general relativity, seeing how space time could be described as a four-dimensional fabric. But it's maybe not as well appreciated, and I think it really should be.
Yeah, it's amazing how long we've known that time isn't something that's a constant. It's something that changes with different curvatures, and yet we still seem so caught up with like causality and cause and effect as
Yeah.
being this like way of explaining everything. But, really a more accurate way of describing it would be with emergence, that there are just these phenomena that emerge at different layers. And it's like, we are very familiar with our layer here as, humans in the 4 dimensions we have access to. And we can go lower and look at the cells and see, oh, there seems to be something similar going on like a smaller micro level here, with which is kind of like its own little universe. but we rarely seem to look at the higher levels of emergence above us, like,
Right.
cities, civilizations, all beings, all earthlings, like, and
Yeah.
whenever you try to say like, okay, well, what's the scale of this thing? Are we just, insignificant little like fungi growing on some small planet in the Milky
Right.
Way? Or are we like, is the whole universe just on one like hair of some giant universe that we don't have access to? It all depends on what you're comparing it to.
Yeah.
So that's why I love like how you've actually not only done the legwork to sort of see how these particles interact, but actually to create a visualization. And I was playing with your model before we got on this call, which is just like amazing, fun
Oh,
to
the Elementary
do.
Particle Explorer.
Yeah,
Yeah, that's fun. Yeah, it's lets you show via geometry how elementary particles interact according to charge conservation, which gives you almost everything. It shows you almost everything that can happen, which is really what
yeah.
physics is about, is what can happen.
I was fascinated that the center of that model is the photon, and it seems like that's just one of the keys to unlocking the mysteries of the universe is with light. And some people have said maybe it's related to consciousness in some regard. Um, but I don't know if you have thoughts on like the significance of light or what role that may play in understanding.
Well, in the model you were playing with, you're looking at the charges of different elementary particles and how those charges are conserved. And the reason the photon's at the center of the diagram is the photon has zero charge.
Hmm.
So it doesn't have electric charge, doesn't have weak charge, doesn't have strong charge, doesn't have gravitational spin, nothing. Okay, and that's why it's the center. It has zero charge. So it's sort of the balance point that everything else is around. Now, as well as photons there are also some gluons and weak particles also have zero charge.
Hmm.
And and this has to do with the geometry of this smooth high dimensional shape that's being described by these charges. For how this interacts with consciousness, I think consciousness feels very unusual in the universe.
Hmm.
And this is also why our level of emergence might actually be quite a special one,
Hmm.
because as you start out with subatomic particles and go up to atoms and then molecules and biological structures and higher up until you get to us, you have increasing layers of complexity and computational capacity and just more richness in the systems. But then when you go up higher in scale, when you go up to collections of people, a mob of people, or even governments, they seem to be less intelligent than many of the individuals that make them up.
Hmm.
So I know I have many friends who are much smarter than any government on the planet.
Right.
Right? So humans as a whole seem pretty damn dumb. We don't even seem smart enough not to shit in our own bed. Right? We're changing the climate to make it uninhabitable for ourselves. And even though members of our human society are brilliant and can see this happening and say, "Hey guys, we really need to stop doing this." Right? Humanity as a whole, as an organism, is fucking up its own environment, which is one of the
Yeah.
stupidest things you can do. We're just not smart enough as a whole not to do that. And this might even be the answer to the Fermi paradox. This might even be why we don't see aliens swarming around in the galaxy. It might be that it always happens that on a scale of a society, it's just not smart enough and it always self-pollutes until it self-limits.
Interesting.
Yeah. And this and also as things get larger, as you go to planetary scales, I mean, in a certain sense, a solar system looks like an atom, right? And you have all these different stars. We have like 50 billion stars in the Milky Way or something. That's a pretty big as an organism. But the thing is, the time that this thing has had to evolve isn't really long enough for complex interactions to happen, say, between galaxies.
Hmm.
The whole universe at 14 billion years or something just isn't old enough for a ton of communication to happen and for structures to form and for emergence to take place. So we've had some structure formation, sure, but not enough for really complex behavior to happen. So it might be that at our physical scale of a couple meters, which is sort of in between on the universe from the smallest possible subatomic scales all the way up to the largest possible cosmological scales, we're sort of right in the middle. That could just be where the richest,
Yeah.
you know, level of emergence happens. It could be in between these big scales, which is where we happen to sit. And I don't think it's a coincidence we sit here. I think we're here thinking about this because consciousness is one of the most richly complex emergent things that can happen.
Yeah, totally. And I've heard consciousness described as the substrate of reality, like what reality's in. Or I've heard Alan Watts talks about how you could think of reality as like sort of like a dark room where you can't really see any image until the solution is there. But once you put the image in the solution, which is consciousness, the whole picture comes into view, and you can just see all these phenomenal patterns. And this gets into just viewing reality as information, which maybe is not so special when there's no conscious beings interacting with it. But once conscious beings are interacting with it, then it creates all of these incredible, geometric patterns and, synchronicity. And is that sort of, do you think like reality as information is our most accurate way of describing it?
There's been a lot of thinking in that direction lately. And I think part of that is motivated by the lack of progress in other areas of fundamental physics.
Mm-hmm.
Some people
Like
have
string theory.
had time on their hands to go out and explore these other things. But I'm pretty much a conservative, crunchy old scientist in thinking that consciousness is more something that human brains do, right? That really it's very much attached to the neurological process itself, and that it's not that consciousness is fundamental in the universe in any way. It's just consciousness is something that happens, and that we are perceiving our own thinking and are aware of our own thinking, and that it's that perception of our own thinking that we really have as consciousness.
See, I've wondered about this a lot, if whether consciousness is something that sort of pervades the whole cosmos, or if it's
Right.
something that's more of an earthling phenomenon. And I also wonder if when people talk about God, are they talking about the highest layer of emergence in the whole cosmos, or is it really just the highest layer of Earth? And like you could even call like Gaia is God, and to some extent.
Well, you can do that, and I think it's wonderful to sort of extend biological thinking to the whole planet. And I think the Gaia hypothesis is a good one, in thinking of the Earth as a living organism. But I don't see any reason to attribute consciousness to it. I think consciousness is something that it requires a more dense, interconnected collection of things, like neurons in our case. And it's I don't think it's unique to this planet. It would be highly improbable that there aren't other conscious alien beings out there in the galaxy, given how many stars and planets there are around stars, right? Just running probabilities. I mean, it's possible life is exceedingly rare, such that there aren't, but it's unlikely.
So would you say that, like, with at least sticking to Earth, where would you say consciousness begins? Because, some people would say that, okay, a protein is conscious, but once you get to the cellular level, it's not conscious. Or others would say that, even a rock is conscious in some very low level way.
Right.
And that gets into panpsychism. I'm curious what your thoughts are.
Um, I have a more functional view on it, and I don't have a hard and fast definition of consciousness. I'm not sure anyone has a really perfect one, or even could. It's certainly something I think we'll learn a lot more about as we have better and better machine intelligence, because I think we will, perhaps within some of our lifetimes, have machines that become smarter than us in almost all ways.
That was one of my questions, actually.
Yeah. And I think once that starts happening, we're going to have a much better handle on consciousness and what it is, and what it means for say, a consciousness to be duplicated. Like if you have a copy of yourself, which is something we can't do as humans, but it's something computers are going to be able to do quite easily. And that's going to be freaking weird. but no, I don't think things like rocks have any significant level of consciousness. I do attribute a scale of consciousness, according to functional complexity. So I think like dogs and pets, I think they're conscious to a certain degree and to a lesser degree than we are as humans, although maybe more so than some humans. Um,
One of my dogs is really smart, and one of them is definitely not smart. So I always wonder, like,
yeah. So I do attribute different levels of consciousness, and by the time you get down to a rock, pretty much zero.
right. What do you, this might be an out there question, but what do you make of people who are referred to as like old souls? Like, it does kind of seem like maybe some conscious energy has just been around for a lot longer than others, and some people have that kind of feeling to them where it's like they've lived for thousands of years, whereas someone else is like a new soul and everything's exciting and they don't have that same quality.
Um, I think it's an interesting way of understanding people, and there are all sorts of. I mean, as we're all sort of growing as humans in childhood and up into early adulthood, it starts to occur to this that not everybody else is exactly like us. And whether someone's more introverted, more extroverted, more dominated by feelings, more dominated by thinking, or if they seem like a more evolved human, like you call them an older soul, as opposed to someone who's sort of like bouncing around from one idea to another and not really organized in their thinking or feeling. It seems like, wow, maybe they learned more in past lives or something, and that's why they're so mature now. It's like, no, I think they just learned more in this life,
Hmm.
and maybe their brain was structured to be able to learn more quickly, or maybe they just went through more shit growing up, and are more developed as a result. So that that now they seem like a more mature person and like an older soul, even if that happens at a younger age, or even if you're like 16 years old, but behaving as a more highly functioning being, that can totally happen,
Yeah,
right? And some people can be 50 years old and never have gotten there
right.
for various reasons. And so I don't attribute any mystical uh, functioning to any of this. I'm a
Yeah.
scientist, right? So I'm much more of a materialist, but I'm a romantic materialist, and that I have a wonderful appreciation for nature and its beauty, and our place in it, and how wonderful life can be, and all this stuff I think is fantastic. So I have even though I'm a materialist, I'm a positive materialist. I like
Yeah,
to.
totally. Okay, well, I want to hear your romantic materialist view on death also as it relates to consciousness. So let's say, you're out surfing and you see a seal that gets eaten by a shark. Does the
Yeah.
conscious energy of that seal like become part of the shark along with its actual physical body? Does it disperse and is just sort of spread throughout the universe? Is it like, okay, that seal is just dead, like there's nothing remaining of its conscious energy? Like how do you think about death and what happens after it?
Yeah, I've used a similar description to really annoy vegans, which is that by eating a cow, I'm elevating that cow to a higher level of consciousness. But I'm pretty sure the cow doesn't see it that way.
Yeah.
Um, and actually, veganism is with the more ethically pure course. Damn it! But um, the uh, and your original question was
Just
death and how's that dealt in a materialist way. Yeah, it's a I think it's a dark subject, and I think most people actually delude themselves in various ways to avoid this subject because it's so fucking terrifying.
hmm.
To me, I think death is just the act of not existing at some point.
Right.
So I don't know if you've ever been under global anesthetic for some surgery
Hmm.
where
Yeah.
they put you under and you're just gone and then you're back.
Hmm.
Well, I think when you die, you're just gone. Your consciousness ceases to function because the substrate that depends on it, your brain has ceased to function. So your consciousness is evaporated in nothingness. And
Yeah.
I don't think consciousness can persist beyond the functioning of some sort of substrate, whether it be your human brain or whether it's being simulated in a computer,
Hmm.
or however that consciousness is happening. Because I think consciousness is more of a verb.
Hmm.
Um, I think once the physical substrate breaks down, the consciousness evaporates, goes away.
Right. Well, what
And
about the concept of that if you've lived for 1 second, in a sense, you've lived for eternity because time is something that, maybe we only have access to it in, the arrow of time, as Stephen Hawking says. We can't really move.
yeah,
But you could imagine like a higher layer of emergence where you can sort of traverse time. So, in some sense, would you say that if you have lived for a second, you kind of live for eternity? Or, I don't know, how do you think about
well, I mean,
life and death
it
in
is
regard to
freaking
time?
amazing to have been alive at all
Yeah,
during
yeah.
any period of time. And it's extremely unlikely given how you look at it. But and looking at the universe as a four-dimensional space-time whole, then yes, if you're alive, you've been alive, and you always will have been alive,
Hmm.
right? But I mean, as someone who's currently alive, I'd rather be happy and healthy and living as far into the future as possible.
Yeah.
I want to maximize my own healthy, happy years. A lot of people wouldn't, which is sort of shocking to me. A lot of people would say, "No, I'm not comfortable with like unnaturally extending my lifespan."
Right.
But we already unnaturally extend our lifespan through, through medicine and healthy living and everything we possibly can. So the idea that we wouldn't want to do that more in the future is really bizarre to me. I mean, the other way I think about death, and the reason I'm not at all comfortable with it, and I want to extend my own life as much as possible, is just FOMO.
Hmm.
Right? I don't want to miss out on all the wonderful stuff that might be happening in the future.
Yeah.
Right? I'd rather just be there for it and get to do that stuff too. So,
Totally. Yeah, we
um,
had David Sinclair on this podcast, and he's doing really interesting work in anti-aging. So we may
yeah,
make some more progress there than people expect.
I'm really happy. I mean, it's only been in the last decade that longevity research has become mainstream. It used to be, it's like, oh, no, fountain of youth, it's a bunch of BS, that can't happen. But there's no reason from physics that we can't extend our lifespans indefinitely.
Yeah.
Right? And it's an engineering problem essentially, and so it's wonderful that research is being done that way now. And of course, there are like crazy things you can try, like cryonics, where you
Hmm.
freeze your brain or something you're dead, and maybe can be scanned in and revived somehow or simulated or something, and come back to life that way. But that's really a long shot.
Yeah.
But
Totally.
yeah, as far as, I mean, going back to death and how hard it is to deal with, especially these days when we're in the middle of a pandemic and an unusual number of people, especially older people, are dying. It's really heartbreaking. I hate losing people, and a lot of people who are religious, comfort themselves that people are going to live on in some way. But as a materialist, I confront this head on, and I really just think we've lost those people, and it's heartbreaking. And
Hmm.
that's why we need to, do what we can to, extend quality life as much as possible, so it's less heartbreaking. Um,
Totally.
and there are arguments in both directions. Like it seems, I mean, when we're consciousness and feeling, it feels like this is something that is eternal. It feels like we should go on existing in the universe in some way. And yeah, maybe a way of looking at it is when we die, our consciousness merges with that of the cosmos, and that's a
Hmm.
very natural process. And you can try to make your peace with this as just being part of nature, which it is. And a lot of people make their peace with it that way. A lot of people, fool themselves in thinking they're going to some afterlife. I don't think that's going to happen. Um, I think, when you're dead, you're just dead. And it really bothers me that since they're going to be dead, Christians are never going to find out that they were wrong. But um, And as far as consciousness and whether consciousness might persist beyond death, it's just not realistic. I don't know if you've ever, it's horrible. I don't know if you've ever lost anybody to Alzheimer's disease or one of these degenerative brain diseases.
My grandpa, yeah.
Yeah. So I lost my grandmother to Alzheimer's disease, and during the progress of the disease, I just saw her consciousness go away, change and go away little bit by bit by bit until she was gone.
Mm-hmm. Yeah.
So there's a very direct connection between a functioning brain and a functioning, happy, living consciousness, and those two are inextricable, as far as I know.
Yeah.
Yeah.
Yeah, totally. I mean, we'll have to see if we can ever get to the point where you can upload your brain to some, silicon version, or if you
God, I hope
could.
so. That'd be freaking
Right.
awesome. I don't know if you played in virtual reality, but VR
Oh,
games do get
yeah.
so.
Yeah, it's amazing. Well, so that's actually a good segue because I want to get your thoughts on the simulation hypothesis. And, many people have made arguments that if we make any progress whatsoever, eventually our virtual reality games will be just as real as the real thing. And given, how much time has elapsed since the Big Bang and whatnot, it may be that we already are in a simulation for whatever the base reality or civilization has created. So from that perspective, it seems way more likely than not that we are living in a simulation. And if you were in one that was so real, how would you even know? So
Right.
I'm curious to hear your thoughts on this.
I think well, I mean, there are a couple of things. One is I don't know if it's reasonable to make probabilistic arguments when you only have one data point,
It's like the
right? So we only
anthropic
have this
principle.
one universe that we know about, and we can argue that, yeah, we're simulating other universes within this one, but they're super primitive.
Hmm.
And there's nothing that rich yet, so it's hard to make probabilistic arguments that make sense that way, since we only know about this one universe. Also, you can say the words base reality, and we sort of have. I know what you're meaning by it, but how would you know?
Right.
How would someone who thinks they're in a base reality, how would even know that you are?
Yeah.
There's no way to test it unless you start seeing glitches. Once you start seeing glitches in reality, then you have some evidence. Then that you're in a simulated one.
So the UFO spotting of the Navy, does that count as a glitch?
No, that counts as seeing weird shit. And nobody knows what it is. I mean,
Yeah.
it's possibly aircraft of unknown origin.
Right.
You don't know what that is. Uh, and if aliens have visited this planet, and I don't think they have because of the vast distances in space, and also because humans haven't been around that long.
Hmm.
So I think it's unlikely that anybody knows we're here yet. So
Yeah.
even though there billions and billions of other stars in the galaxy, and our signals are going out into space, so aliens are going to see that we're here eventually. We've only been broadcasting radio waves for a couple hundred years,
Hmm.
and if you go out a couple hundred light years into the galaxy, you only get to maybe 10,000 star systems, not billions. Right?
Right.
So our announcement of, hey, this is a terrible television show. We're somewhat intelligent, but not very. That signal's only gone out to a few thousand other star systems.
Yeah.
Right? So and it's possible some alien civilization has listening posts up to look for this sort of thing, and they'll find out we're here. But it's going to take a while for anything to get here, since I don't think anything goes faster than the speed of light, according to known physics. And we're reasonably confident in known physics. So,
Yeah.
um, so
Yeah.
it's
No,
gonna.
I hear you, and I think that I also hear your argument about base reality. Like, it's so hard to create a mental image of what reality is, just given how much we know now. But I actually find surfing to be a helpful way to just sort of get yourself out of your own head, especially when you're like duck diving under like a massive wave
Yeah.
and you're just being like churned up in this cosmic soup. And I often find myself thinking of reality in terms of like the ocean and waves. Like we're sort of like a splash of matter, like, and consciousness going in one particular direction along the arrow of time. But there's probably also like other realities that are mathematically possible going in slightly different directions or different versions. And I know you don't love to think about other universes outside of this one because it might not be as useful. But
No, I do. I just think it's more philosophical than scientific because we
right,
don't have experimental access to it. Remember, science is all about testing, and you can't test the existence of other universes if you don't have access to them and they have no effect on ours.
yeah, totally,
So, but I love philosophy. I love talking about other possible universes and even considering that mathematically. Once you start considering it mathematically, you can sort of bring it into a scientific view, but you can never have experimental access to it. So in that sense, it's not really science.
yeah, totally,
But that doesn't mean I don't enjoy thinking about it and and considering the idea. And whether we're in a simulation, I mean, one of the reasons I think maybe this might be a base reality, even though who knows how he could ever determine that conclusively, is the richness of physics itself,
hmm.
and just how hard it is. So if you're going to have a simulated reality, it would be much easier to have a simulated reality that's more easily computable.
Hmm.
So like something like the Conway's Game of Life going on, right? It's sufficiently complex that you could construct biological creatures that run around and interact with each other on this two-dimensional grid of propagating ones and zeros, right? With simple rules. You could build a full civilization and perceiving and computational system and consciousness within that simple set of rules, and it would be really easy to compute,
Hmm.
right? And Wolfram's working on these lines too. But when we actually look at physics, I mean, at quantum field theory, and just the convoluted agony that a computer has to go through to simulate the simplest things going on in quantum field theory, for subatomic processes. I mean, it's so hard to compute, like what's going on with quarks and gluons inside nuclei, that it leads me to believe that this is not a simulated universe, just because that would be so hard to compute at scale.
Right, right. Yeah, it does seem to operate more like an organic process that's just growing and flourishing on its
Yeah,
own rather
and,
than like
and
a,
there and there
yeah,
there's just complexity everywhere to an extravagant degree that
yeah,
you don't even see. I mean, you can be going on a walk and it's like, all right, I'm going to stop suddenly, randomly, look down at this 1 square millimeter of stuff, and oh my God, look at everything going on there.
yeah,
It's just like an incredible richness down to and that's going on all around us. I mean, it would be so ridiculous to compute that, and for what? For what purpose?
yeah,
As far as we know, the universe has no objective purpose, and
exactly.
we
It's
just
like,
happen to be here living in it. So it's really up to us as humans to make up our own purpose.
yeah, I'm totally with you. And it feels like so much of science is trying to find like clean explanations for something. Like, why does the butterfly have the little dot on its wing? Oh, well, that's to scare off birds. And it's like, well, okay, so why does this other bird that clearly is not good at surviving because it has got all these, like a peacock, for instance, like, oh, well, that's to attract mates. And you can come up with a reason for each of them. But you could just as easily say, like, well, how boring would it be if it was just a bunch of amoeba living in perfect uniformity? So there
Right.
might be some of the element of what we experience, in our own reality at this level of emergence, where things are beautiful. We do value variety. There is this dance moving, like even the fact that when you're born as a baby, you naturally have like rhythm in you. Like if music
Yeah.
plays, you dance. Like who's to say that that doesn't also represent itself on some other layers of emergence, whether higher or lower? Why does it have to be just like purely dead mechanics? That
Right.
is so often how it's explained.
Um, well, I think of it as live mechanics, but also, I mean, it is the scientific view of analysis to take things apart and look at the interactions between the parts in order to understand things.
Hmm.
So when you do that, you sort of have to put blinders on and just focus on the one part that you're going to try to understand. Otherwise, everything else comes in and messes with it.
Right, right. Yeah.
So yeah, that's why the reasoning seems so basic, is because you've ignored everything else, and maybe you've gotten to the crux of the matter, but maybe you're totally missing it, and that happens all the time.
Yeah.
Yeah. So I mean, but you have to be aware of this and in looking at things and looking for explanations of things. The funniest thing I see all the time, since I'm also interested in stock investing and do that to support myself, is looking at stock market movements, and then you look at the analysis the next day, and the analysis next day comes out as if there were very basic reasons for why this happened. It's like, no, the whole thing is such a complex system. There's no way these basic reasons were like actually the reasons why this happened. It's
Right, right. It's 2020 hindsight.
yeah.
Yeah. Awesome. So I have some rapid fire questions for you, but I want to maybe before that just get an update on E8 theory and if there's any sort of, tests that are planned with Kern, because, one of the things I really like about your theory is that it is testable. So whereas a lot of string theory is very theoretical and you might not be able to test it, there are
Right.
particles predicted by your model. So I'm just curious if there's any like update on tests that are planned or even other particles aside from the ones you predict if there's any tests planned.
Right. Well, so I have to fill in a bunch about that. When I put this proposal forward in 2008 or so about unifying particle physics within this E8 model, there were a lot of blanks left out, and it implied that there should be some other bosons, some other fundamental Higgs particles.
Hmm.
And since then, we did see the main standard model Higgs that was also predicted by this E8 model in
Right.
2012 or so, and which is wonderful. We have seen no particles since then. We haven't seen superparticles that I don't think should exist, but we also haven't seen new colored Higgs, which is this E8 idea predicted. But the other thing I want to say is when I put forward this E8 model, it wasn't complete,
Hmm.
right? So although it did suggest that these other bosons should exist, I didn't yet, and I still don't have a perfect match to the known elementary particles.
Hmm.
So as well as the electrons and the up and down quarks that we know of that make up normal matter, those do fit in this E8 pattern. But there are these other second and third generations of matter particles that don't yet have a good description within this E8 model, right? There's this vague suggestion that they might be described by triality within this model, but I've never been able to get this to work, and neither has anybody else.
Hmm.
So I've largely moved on to other things, sort of giving up on getting that to work. Because before for any physical model you're working on, before you start making predictions with it that you have any confidence in at all, you have to match up with known physics, and there's a ton of known physics,
Yeah.
right? And
Right.
currently, I don't even have a good match to known physics. So this is why this model is incomplete, and I've never put it forward as a complete picture or even as a potential complete picture, but rather just as an interesting observation and direction to look in.
Yeah. Yeah.
Yeah.
Well, I love how you know, I feel like we've been exploring the string theory line of, for so long since like the 1970s and haven't really had much, results from that. And
Yeah, it's
so
full of crazy ideas and broken promises is what it is.
yeah, and to me, it also feels like going from the geometry side, it just would be more useful to be able to think of it in a way that we can, visualize to some extent. A lot of the quantum mechanics, it's just so hard to wrap your head around that it's like, how useful is it other than making very precise predictions? So I wonder, do you feel like the model in academia itself might be a little bit broken where there are so many entrenched interests with having already gotten this grant money and then they
Yeah.
want to show for it and they've published all these papers so they kind of need it to continue rather than just focusing on coming up with as many disparate ideas and bringing
Yeah.
together as many viewpoints to come up with like the best of all worlds.
Yeah. I mean, really what happened is there was a culture in particle physics of things only progressing along the hottest ideas, right? So if you have some new particles showing up, you put together theories for how these new particles are interacting, and you go forward with that and develop that with very rapidly, and everybody sort of piles on that bandwagon and go and make progress in it. And hey, look, this worked. We figured this out, and everybody's doing the same thing in the same direction, and things proceed that way. But we haven't had new particle physics experimental results to do that with in many, many decades. And what has happened is the bandwagon effect just kept everybody going in the same theoretical string theory directions without any experimental checks.
Hmm.
So now everybody's barreling forward, and you don't let graduate students go out in their funny weird directions. You pull them back and get them on the hot thing because that's the only way they have any chance of getting a job in the future, right? So everybody's been going forward in the same directions with absolutely no success. So
Yeah.
now everybody's way on the limb. Everybody has their grant support. Everybody is invested in this direction. Not only financially invested in it, but intellectually invested in it, having put decades into studying the subject. Because string theory has gotten so convoluted and complex that you literally have to put decades into it with a brilliant mind in order to understand what's going on,
Hmm.
right? And once you've invested all that, you're invested. You have a sunk cost
Right.
in that area of research, and you can't just split off and do something totally different because then you'd be like a helpless, beginner in this new direction. So it would have been much healthier in the field, in my opinion, given that we don't have new experimental data coming in to check these things, just to let those graduate students go off and explore whatever the hell they want,
Hmm.
right? And this is what my advisor did. He gave me free reign to go off and in some whatever weird directions I wanted to. And I
Yeah.
turned out being very fruitful for me personally, but it was more high risk, certainly.
Yeah, it sort of reminds me of what you said earlier about how like individuals are often smarter than like a
Yeah.
top-down rule. So if we can empower individuals to explore whatever paths they find compelling, and starting up with some rapid fire questions, one thing I wanted to ask you about is whether you think, universal basic income would be a good solution here, so you're not always like
You almost got a spit
scrapping
take.
for
That's why.
But that way, you wouldn't always
Yeah.
be like scrapping for grant dollars. You could actually have some basic level of safety so you can do whatever you want in life, whether that's exploring physics or some other field.
Yeah. I mean, politically, I'm sort of a combination of a liberal and a libertarian. So I call myself a libertarian. And I think given increasing automation and increasing developments in machine learning, I think universal basic income is inevitable,
Hmm.
right? Because if without it, we're going to have people starving in the streets,
Yeah.
and we don't want to live in a society like that. Okay, it's just not optimal. As a rich capitalist, you don't want to have to make your way through through streets of diseased, unhappy people,
Yeah.
just because it'll
Yeah.
bring you down. How can you enjoy driving around in your Ferrari when they're bums, heaps of bumness in your way, right?
Right.
So yeah, you want everybody around you to be having as fulfilling of a life as possible. And one way to sustain this is to have a minimal amount of universal health care, basic living expenses available, just to provide a minimal roof over your head and food,
Hmm.
right? And as a society, um, given the immense resources we've developed over time and the progress of science and technology to support humanity, we can totally do this,
Yeah.
right? And even with all the fighting against it, and in my mind, Republicans are mostly just greedy. But even they, during this pandemic, have had to give out support checks for people. And now we just found out how easy it is just to give everybody a bunch of money, and that's the way it should be done. We shouldn't be giving support to huge corporations and banks and hope that there's a trickle down effect to the common guy. No, that's bullshit. They'll just give that money just goes to their shareholders.
Yeah.
I mean, okay, that's me, but I don't need it. I don't I don't need a boost from the government. I'm a pretty happy capitalist.
Yeah.
But people who aren't doing well, people who are struggling to live paycheck from paycheck, absolutely, I think UBI is going to be the way to go. And yes, not only will it support people who otherwise couldn't support themselves, but people who are brilliant but simply don't want to work at some menial job to support themselves and would rather dedicate themselves to artistic pursuits or to furthering science. They could take that UBI and just be living off that dole and doing something that ends up being incredibly productive for humanity as a whole, even if they're never financially compensated for it or get paid to do it as a job. It sort of disconnects, because right now, I mean, the amount that science has benefited humanity,
Yeah, it's
right?
amazing.
Yeah, and that doesn't really go back to scientists.
Right, right.
I mean,
Yeah.
I mean, scientists tend to have a fairly higher status a little bit, and they tend not to starve just because they have huge brains and not going to let themselves starve.
Hmm.
But they have to work for it, and it would be nicer if they had more support and more benefit because of all the benefits that they're providing for society. But I'm very much not a communist. I don't think that. I think that if you remove the incentives for people to work, that most people just won't work.
Right, yeah. It's important to just raise the floor, but you still want to have the ceiling be super
That's right.
high so people are incentivized.
That's
I'm
right.
with you.
That's exactly right. Yeah, so I'm totally on board with that, and I think that's the way to go. And I think uh, ultimately, um, I mean, this sounds unpatriotic, but I guess I'm not much of a statist. But I think the United States has become more European in that sense, with increasing social services, become a little bit more of a welfare state with stronger support, less military spending, and we might not be militarily number one anymore, and we'll have to deal with that.
Yeah,
Have to kind of get our national ego in check a little bit.
right.
Yeah.
Yeah, that'll be tough. Okay, well, I have another related rapid fire question. So you said that you believe machines will eventually become smarter than the average person, which is, artificial general intelligence. I'm
Hmm.
curious how long you think it will take for that to happen. Like, do you think that by 2050 that could happen? And then my follow up to that is, do you think that consciousness will arise in sufficiently complex machines, just by the very nature of how intelligent and complex they are, or maybe they won't arise and they'll be super intelligent without consciousness? I'm curious to hear your thoughts.
Um, I think the answer to all those questions is yes. Even the contradictory ones, even the
Right.
contradiction you provide at the end, because um, there are a few interesting caveats though. Because if you look at the increase in supercomputer power and what computers are increasingly do in terms of the density of components on a chip and how Moore's law and how the increase in computer power seems exponential. If you just follow that exponential, if that keeps going as it appears it has for quite some time now, then yeah, we're looking at around 2050 for having the computational power of the human brain. However, what's not decreasing exponentially is the cost of computation.
Hmm.
Okay, and especially the energetic cost, right? So the cost of computers has also been going up linearly.
Yeah.
Okay, and in terms of energetic cost. So although it'll have these computers as they get more and more power, they'll have this increasing computational power, but that'll come at a greater cost. So although we'll have these increasingly intelligent machines, they'll be very expensive to run.
Yeah. We'll have to create a Dyson sphere around the sun.
I've always liked ring worlds. I think they're more elegant engineering solution than a Dyson sphere,
Oh,
especially
yeah.
well, mostly because we don't have artificial gravity. So how do you get the gravity thing figured? But if you have
Right.
a ring world and you're spinning a ring world around the sun, then you get the centripetal acceleration gives you gravity at the surface of the ring world and holds everything in. So I
Yeah.
think that was a great idea. Um, yeah. Plus
Yeah.
Larry
Well, I
Nichols
love
was
Halo. I play Halo, the video game, and that's like all a ring world.
yeah.
Um, okay, I have another question.
Wait,
So,
wait, wait.
oh yeah, go ahead.
I was just getting onto this one. So yes. So I think the time scale for machines exceeding human processing power is around 2050 if you continue that exponential. But I think it'll be expensive, and I think a lot of those computers will be run by corporations because they'll be the only ones with the financial resources to run them, either corporations or nations, or both. And they'll end up making the corporate decisions.
Hmm.
So that so super intelligent machines will end up making hiring decisions. Because you'll
Yeah.
have machine learning algorithms pretty quick being able to tell who good employees are going to be.
Yeah.
Um, uh, but it's going to be cheaper to employ humans because there's more
Yeah.
available. But the computers are going to be calling the shots more and more because they'll get smarter and smarter. Now, and eventually, I do think you'll have computers that are so smart and they're sufficiently self-aware that it's going to be impossible not to consider them conscious.
Hmm.
And and then there's also this questions like, well, you're gonna have to give them rights like people. Well, no, they're gonna have rights as corporations.
Mm.
Corporations already have rights, and that's already a good vehicle for a machine intelligence is to exist as a corporation. So our corporations are going to be machine run, and they're going to be the physical instantiations of these super intelligent machines that are
Right.
interacting in our world, and they already interact economically in our world. So it's already going on. It's just currently they're run by stupid computers and people, and the computers are getting smarter.
Right.
Um, so yeah, so yes, they'll be conscious, but there'll also be just as many cheap computers that are much cheaper to run that are not conscious, but there'll be a grayscale too.
Yeah.
And
Now,
then also, with sufficiently complicated computers and sufficiently good scanning technology, we might be able to upload human consciousness itself onto a machine substrate,
yeah. Yeah.
which is going to get freaky weird.
I know. I've already had to promise my wife that I won't do that if it ever becomes an option.
Really?
Yeah,
Oh,
even though I probably on my own I think it's a good option, but yeah. So I'm curious, what do you view as the single biggest threat to human civilization? Is it AI? Is it climate change? Is it nuclear war? Like,
well, pandemic is
is
currently
pandemic
really
is a good contestant? Yeah.
existence level threats or existential threats.
Yeah.
There are lots of things that could send us back to, Stone Age technology.
Hmm.
Um, Big meteor strike, really bad pandemic, machines deciding they'd rather not keep us around.
Hmm.
Those are the biggies.
Yeah.
Uh, on a longer time scale, just environmental catastrophe, just literally making this world uninhabitable for ourselves just by burning shit,
Hmm.
right? I mean, the fact that that we still have a predominantly petroleum-based economy, even though the price of oil just went negative.
Yeah. Yeah.
I mean, there's just so much of this stuff, and we've gotten so good at pulling it out of the ground and burning it that it's just a huge tragedy of the commons,
Hmm.
and humanity as a whole just doesn't appear to be bright enough to stop doing this, and we're gonna make our own atmosphere unbreathable by us.
Yeah. Yeah, I know. It's
But we won't.
worrisome.
But is that extinction level? No, because we might make little oxygenated bubbles that we live in, right?
Yeah.
It's just going to be different. I mean, it's gonna suck more environmentally, but we'll still keep going as a civilization. So I think whatever tragedy strikes us, will persist in some form or another, but we might have some significant setbacks. This pandemic we're currently enduring is a pretty significant setback. When we
Hmm.
have more widely available CRISPR kits, and any biohacker with the desire to can engineer some virus worse than this one and set that loose on the world, that might be some big setbacks.
Yeah.
Uh, Engineers making backpack nuclear weapons and taking them around and blowing shit up. That might be big setbacks. So humanity has all sorts of setbacks like this in its future.
Right.
But overall, I'm a techno optimist, and I think overall we'll keep improving quality of life in general. It,
Do you think there's anything that could stop emergence itself? Because, you could say that, yeah, humans, we may create some virus or an asteroid may wipe us all out, just like they wiped out the dinosaurs. But just like how the dinosaurs' heyday ended and then mammals took over and created all these amazing things, maybe, the planet of the apes will get wiped out of all of us like high level apes, and then it'll be like super smart fish millions of years from now or something. But is there anything that could stop this process of like emergence that just seems to be ongoing?
um, on I will laughingly call them the shorter time scales. No, this appears to be the way the way nature works. Is you have some energy source like the sun, and that goes through some medium that allows the complex operation of all sorts of natural substances to produce emergent layers of complexity that operate and dump entropy out into the rest of the universe. Right, so you have this energy flowing through the system and entropy going out, as well as the waste heat energy, right? And within this, complexity continues to evolve in different forms. So even if humanity gets wiped out, as you say, other creatures will evolve and develop and flourish, right? Nature just sort of keeps going this way, and that'll keep going until all the stars burn out.
Yeah, till the big crunch.
Yeah. Well, no, not a big
Or the
crunch.
heat death of the
Yeah,
universe.
yeah, it's a heat death. So we have this dark energy driving the accelerating expansion of the universe. So the stars burn out, they get swallowed by black holes. The black holes evaporate until you have nothing but radiation in the universe. But because the universe is expanding, the radiation itself redshifts into nothing. So you just have this vast expanse of nothing in which nothing can happen.
Hmm.
But that's like
Yeah,
trillions and
yeah.
trillions of years from now. I mean, it's like
Well, it's good
I'm
to.
worried about it'll be great just to make it to the next 100.
Yeah, exactly, exactly. Yeah, it's good to know we don't have to worry about progress and flourishing and emergence as a whole. It's just our particular little like micro timeline.
Yeah.
Um,
But our micro timeline is certainly interesting. I mean, this pandemic is going to change things. We're going to have more people interacting online. We're going to have fewer group activities. Fewer getting together in bars. Less getting together for sports events. Less getting together for everything.
mhm.
Extroverts are kind of hating life right now, where introverts are kind of like, nah,
Yeah.
I'm kind of comfortable with this.
Awesome. Well, I want to get into the future scenarios now. So let's start with the worst case scenario. So I want to get a sense for, in your mind, what's the worst case scenario for how physics and just our understanding of reality would evolve in the next, 10, 100 years?
Worst case scenario.
Um, 10 years, if we just keep going with the same bandwagon,
Hmm.
right? And they keep declaring success, right? And they succeed in divorcing themselves from the scientific method, saying, hey, the scientific method is no longer to test things. The new scientific method is to propose ideas, and the community decides whether those ideas are good or not,
Hmm.
right? That's the
Hmm.
way string theory is going. And that's horrible, right? And so that's worst case for the next 10 years.
Best case scenario.
Better case would be maybe China steps up and builds a much larger collider, and we actually get some new data about new particles coming in that support theories going in different directions, right? So that we have more of a golden age again of particle physics with more data on the ground to play with and get more insights into fundamental physics.
Yeah, and in the best case, what could we discover? Like in your wildest dreams, what discoveries would we possibly be able to make like in our lifetime? Whether it's specifically through the Large Hadron Collider or just other technologies, whether it's time travel or warp drive or extending longevity, or like what are the inventions that really excite you when you think about future potential?
Um, the most exciting one for me is absolutely longevity,
Hmm.
right? Happier, healthier life for longer.
Yeah.
Okay, that is absolutely has the largest potential for improving life, not only for me personally, but for humans on the planet.
Hmm.
Right? Also, when people live longer and they know they're going to be living, say, for thousands of years, maybe we'll take better care of this place,
Yeah. Totally.
right? Now, I might not paraglide as much, So if I know that, without some accident happening, I'm going to live thousands of years, I might be more cautious.
Right.
Okay. I'd probably still surf.
Yeah.
Surfing's safe. But paragliding is a little on the riskier side. But, I've only got like maybe 40 years left. So I've got less to lose. And paragliding is pretty damn fun. So I'll probably keep doing that. But yeah, longevity absolutely has the biggest potential. In terms of other stuff, really smart computers is going to make a big difference.
Mm-hmm.
Right? And maybe with the computers running stuff, they'll make better decisions in general than humans are. Maybe that'll overcome this phenomenon of mobs of humans being dumb.
Yeah.
Right? Maybe mobs of humans coordinated under the leadership of really smart and compassionate machines will do better. Also, I'm really happy to see photovoltaics for energy protection increase.
Yeah.
I think that has great potential. We really need to stop burning stuff.
Mm-hmm.
So those are the most practical things I see as improving our future.
Do you think quantum computers will play a big role? That seems like the next major area of investment.
So I think quantum computing has a really bright future. I'm not sure on the timescale. I think the timescale might be a little bit further ahead of us.
Mm-hmm.
And I think before quantum computing gets really effective at making more powerful computers, it might also have some progress in optical computing. So doing computations with light and using light to modify the substrate that the light's going through itself, and using that to create logical circuits.
Oh, interesting. Yeah.
Faster. Yeah, because currently, electrons traveling around a chip, it happens pretty fast, but there are problems with how to dissipate that much heat. And we're already down at, tiny scales for how small we can get the circuitry. We're down to the atomic scale already. And so we're hitting limits there. But working with light travels faster than electrons do through circuits. So we can have faster optical circuitry than we can electrical circuitry. So optical computing, I think, has a lot of potential for faster computation. And that'll probably happen in between current computation and quantum computation.
Wow.
And then quantum computers will ultimately have more computational power. So that'll be a pretty good breakthrough too. But I think these will help Moore's law continue along its path.
Right.
Yeah.
Have you seen the show Devs? DEVS? It's on Amazon Prime.
I just started downloading it.
Oh.
But I haven't started watching it yet. But it's on my queue. I'm finding myself with an unusual amount of time to watch shows at night.
Yeah. Well, I won't give anything away then, but I'm really interested to hear, maybe, later I can email you or something, but interested to hear if that is somewhat realistic, the way they portray quantum computers' ability to simulate past and future events. Basically, I don't want to give anything away, but with the computer that they build, they're eventually able to basically turn back time and look at what Jesus Christ actually says on the cross in Aramaic based on the coordinates of, space-time and
you'd have to have, I think that's unrealistic given what we know about dynamical chaos. So you're aware of the butterfly effect?
Yeah.
How, there's some tiny change in one place and you go forward a few weeks and that tiny change has made a huge difference in the state of the system.
Mm-hmm.
And this is the way nature works. We have this interconnectedness of all things where little tiny changes here have huge effects just by running the system forward or backwards.
Right. So you might be simulating a slightly different history if you were to build that.
We're going to get much better at simulating things that can happen.
Mm-hmm.
But because we don't have sufficient data at sufficient detail, because we literally can't, we won't be able to know exactly what did happen in this one timeline. But we'll be able to simulate other timelines.
Right. And that also brings up the question of free will. It's like, well, if you can just, turn back time and see what Jesus said, then did he
I knew
really
you
have the
had to ask
free
me
will to say that? So I mean, yeah, I had to ask you about free will. So
that. Yeah.
what are your thoughts?
I answered them by saying you had to ask about it.
Yeah.
I think we have the perception of free will, and I think that's a valid perception that we have of free will, but that we don't actually have free will.
Hmm. Okay.
So, but that we absolutely should behave as if we do, because for all intents and purposes we do, but not really.
Yeah, no, I'm with you. I think it's you could view it from either side. And I mean, I personally I feel like free will is yet another emergent phenomena, or just action in general. It's like you just do what feels right to be done, and that's both because you internally want it, and it's because of all the environmental influences and just the very fact of what your DNA is and who you came from and your upbringing and all that.
Yes,
Uh,
that the the free will you're experiencing as a result of your neurons firing, as a result of all the environmental input and evolution that's happened to make you you, that's resulted specifically in those free will decisions going on in your brain mechanically as they have to, is yeah, that is the free will happening deterministically.
All right. Well, the final question, or just the final main area I want to ask about, is the most likely scenario. So, what do you think, not what you would like to happen or what's the worst case, but what do you actually predict will happen in the field of physics in the next, let's say, 10 years?
Most likely scenario.
In the next 10 years, I think we are going to see a shift, which is going to be uncomfortable for most of the physics community, probably to a Chinese collider for particle physics.
Hmm.
The rest of physics, like solid state physics, plasma physics, like building a fusion reactor, I mean, I think that stuff is fantastic. Biophysics, also really great right now, with very practical import. But I think this is, not a fantastic time for particle physics, because I think it's going to it's had, with CERN being sort of a melting pot of different cultures and nations coming together, all working in this one space on the LHC. I think the next collider might be Chinese, and they'll have very nationalistic control of it and of the results. So that might not be very happy for a lot of the physics community. Especially if they find something really cool and aren't super upfront about disclosing what they find.
Hmm.
Or even if they just name some new particle with the Chinese character, that was going to be kind of weird.
Yeah.
But I mean, we'll adapt. And I'm not nationalistic. I'm happy to see progress made towards understanding fundamental physics wherever it comes from. But the worst case really is that it doesn't get built at all. I mean, worst case is we're plunged into war.
Yeah.
I mean, and that whether that's a Cold War or a cyber war or a drone war, it's not going to be fight with normal weaponry. It's not going to be fought with nuclear weapons or normal weaponry. It's going to be fought with computers and drones. Drones would be the most physical instantiation. That's the worst case is absolutely war and the huge destruction and cost that comes with that. I certainly hope we would avoid that. I hope one of the things we're learning now from this pandemic and just how costly it is to shut things down economically. I think that will hopefully discourage us. And it's kind of an interesting thing. Either it's going to unify the world because we have a common enemy in this virus. Okay, it would be wonderful. It unifies the world and say, hey, we have to work together more strongly to prevent things like this and to recover from what's happened. Or it's going to make things more divisive, and it's like fucking China. This guy had to go eat a bat. It's like
Yeah. Seems like the latter has been more the case, unfortunately.
This really just shit happens.
Yeah.
Really just shit happens, and the world should get better at dealing with stuff like this. We need to be more organized in our responses. We need to be more organized in contact tracing, in a hopefully anonymized way, and we just need to get better at dealing with stuff like this as a whole. And it's kind of shameful we don't have a stronger world government right now.
Yeah.
Right. Just for safety reasons and for response reasons, but realistically, as you're saying, it seems like we'll have more division, and sadly, I think we're going to have more wealth disparity. Because right now, people who are poor and living paycheck to paycheck, everybody's going into more debt.
Yeah.
I mean, over 25% of renters aren't paying rent. And eviction laws are largely suspended. So evictions are largely suspended. People are not paying debt, but they still owe that money to their landlords. So a few months from now, they're going to owe huge amounts of money. It might make sense for them not to pay it. They might just move out instead, which means they'll be homeless or living on a friend's couch. So we're going to get this huge wave of homelessness coming in a few months. Homelessness and people, they'll still be in debt, so they'll still have credit agencies coming after them now.
Yeah.
So
I've read that even with like the $1,200 payments, only 3 cents of every dollar is going to actual individuals, not like companies.
Yeah.
Yeah. So I guess
the money should go to the bottom. It shouldn't be going to the top.
The bottom up.
Yeah. The whole idea of trickle down economics is just a farce.
Yeah.
You want the people who aren't making money, who aren't able to work right now because under quarantine, pretty much everybody should just get a couple thousand a month right now to keep them going through this, and that'll trickle up into the rest of the economy as people spend it.
Totally.
And you can't, and that's not sustainable. That you do that, that'll devalue the currency. But our currency is pretty damn strong. You can take a little devaluing. It's better than putting everybody into debt, because the debt's just going to be crushing after this. We're going to have corporate debt and bankruptcies all over the place. We'll have private bankruptcies and insolvency all over the place. It's just going to fucking economically suck.
Yeah.
But people who are wealthy are going to do mostly fine because they saw it coming more than most did, and shuffled their investments around. So either didn't lose a ton of money or even made money off this thing.
Yeah.
I'm pretty much even. I took a dip for a while, but then mostly recovered, so I'm pretty much even. But I'm just seeing this as being a pretty dark few years economically for people. And freaking, man, millennials have had a rough time. Economically, it's just like, after the recession and now this, they have to deal with. Yeah, this sucks.
Yeah, well, I'm curious, given all that and how crazy things are right now, what advice you would give to our listeners. A lot of our listeners are millennials or they're Gen Z, and either they're in school, now they're taking Zoom classes, they're deciding what their major is, they're deciding do they want to go down a more traditional path or forge their own path in the world, kind of like you have. So I'm curious what advice you have.
The main advice I would give is the value of labor, whether it be physical labor or intellectual labor, is decreasing. And the value of invested capital is increasing. Okay, and it's already hugely imbalanced now, where capital is currently worth much more than labor, and it's going to keep going. And that's what it means. And this is why we have wealth inequality. So what you want to do is, instead of use your brain to work to make money, but also use a bunch of that brain to invest that money. Invest in your own future earning potential. Invest in stuff that's going to produce for you in the future. And learn how to invest in stocks. Maybe install Robinhood or one of these other apps on your phone that'll let you invest easily. Although you should probably complain to Robinhood that they don't allow shorting. That's really annoying. Because Robinhood's like, buy options. You want to do options trading instead of shorting. No, options are usually a crap deal. Because you lose your bet. If you're wrong, you totally lose your bet. Whereas if you're shorting or you're wrong about a long bet, you're just going to lose a small percentage of it. But when you're doing options, you lose your whole bet, and it's usually a crappy deal. It's usually stacked in the house's favor. Whereas investing in stocks, it's usually in your favor. Stocks on average are going to go up. So learn how to invest. Just start with just a few stocks. Use fractional share trading, which is getting introduced, so you can buy like $10 of stocks,
Yeah.
right? And learn how to do that. Learn how to grow your investments into the future, because that's what you're going to be living off of. I guarantee you, 20 years from now, if you're a millennial, you're not going to be living off your work. You're going to be living off your investments,
Yeah.
because computers and others are going to be doing your work, the physical work and intellectual work.
And for their work, like what areas of work do you think would be more promising versus less promising if kids are deciding like what major to do? Or do you think it's just really whatever you're passionate about? Like,
You definitely want to do what you love, but you also have to support yourself. If you need to support yourself and you have the intellectual capacity to learn to program and be happy about doing it, that's a good way to make money.
did you do all your programming self-taught?
I did, yeah. So I started.
Wow,
I learned AppleSoft Basic when I was like 10 years old, and
that's amazing.
sort of taught myself up from there. It's like walked into computer science class in high school and helped the professor work through a course of how to learn Pascal, and then taught myself C from there. And JavaScript is kind of a mess, but yeah, I learned that a little bit. But mostly, I never got really into programming because I went off into physics instead. But I do love it, and it's wonderful to be able to do it, and you get immediate results. The wonderful thing about coding is you get to build stuff and run it and see it run, and your creation is alive and functioning, and you just made that. It's very satisfying.
Yeah.
The downside is it's frustrating, especially now you have all these libraries and packages you have to deal with. It's hard. But anyway, yeah. So if you enjoy it, definitely coding is a great way to make money. But always you want to have 10 to 20% of your brain thinking about the world and good investments to make in the world.
Yeah. It's not just about making money, it's about making money with money. Be another way.
And that's cumulative. The investments you make, you want to think that that's cumulative. That's going to build. And it's not just put it in a bank and it grows at 1% interest rate. No, invest it wisely and grow that shit at 10%.
Mm-hmm.
You grow something at 10% interest rate for a decade, you got some money.
Yeah.
20 years, 30 years, you'll be able to live well off of it, and then you don't have to work some shit job anymore. You don't have to do what anybody tells you to do anymore. You got to have few money.
I know that's the dream. True financial freedom, do what you want, and
And
I guess
yeah,
one good way to sort of bring this home would be, so even if you are able to support yourself fully, what's the benefit of pursuing knowledge and wisdom and understanding the universe? Like, you could from one perspective say, oh, it's all just a waste of time. Like, why don't you just like live your life and be happy? So I guess like for you, like how has gaining a greater understanding of the workings of the universe influenced the way you live your life, or just how you view reality?
Well, there are two ways. One is I know there's no objective purpose to reality, so it's up to us as humans to create our own meaning and to care about each other. It's also given me appreciation for the ephemerality and value of life and our time on this planet. So it's motivated me to make stronger connections with other humans and to grow a good network of friends. And as well as physics gives one a rich appreciation for nature and the functioning of this universe and its structure. So I drive a lot of benefit from it, both personally and philosophically.
Yeah. Well, I think that's a good place to end it. Thank you so much, Garrett, for taking the time today. Where can people find you if they want to learn more and get in touch?
I'm pretty easy to find. Instagram's a great way to keep just to see what's going on in my life. But I talk to most people on Facebook. If you want to follow me there or join the conversations there, most of my posts are public and have public conversations on them. So if you actually want to talk to me, that's a good way to stay in touch. That or Instagram, or just Google me and look at stuff online and stay in touch that way. Or ultimately, if you really want to hang out, come to Maui and enjoy the place and actually hang out in real life, if that's a thing anymore.
Hopefully it becomes a thing again.
Yeah.
Awesome. Well, thank you so much. Thank you to our listeners. This has been The Future of Physics, and we'll see you next time.
All right, Matt, great talking to you, and I hope you get some waves soon.
Yeah, me too. Awesome. Take care.
The past, the present, and the